So we are going to introduce a new measure called moving average. Moving average is basically this concept of calculating the average price in the past, say, 12 days. Okay, so when you're standing at the current date, you just look back 12 days and you calculate the average price. Okay, when the time passes, okay, next day, okay, you move forward one day, again you look back 12 days and you calculate the average price in the prior 12 days up to the current day. So as we move on each day, this average also moves on, okay, because we only consider the past 12 days based on the current date we are standing at. Okay, so this is a moving average concept. It helps to kind of smooth out the daily fluctuation in stock prices. We are kind of looking at a relatively long-term trend. For example, 12-day average is basically giving us an idea about what's the average price in the past 12 days instead of more volatile daily fluctuation. So to do that, let's first open a new report page because we need to. The purpose of having a measure is to show it on a view. Okay, and the view is usually presented on a report page. So here, once you open a report page, just click on this button, new measure, and I'll just paste my definition of this measure here. Okay, so eventually this measure is going to be shown on a view in this report page. And here we have several steps to kind of complete this definition of this measure called MA_D, standing for moving average on a daily frequency. Okay. In the first step, again, here we use the variables. Okay, the intermediate variables in a DAX code to help implement this definition in several steps. The first step, we use the window function. And the window function is going to work on this historical daily data set and retrieve certain rows from this historical daily data set. Okay. First of all, we notice instead of using just the raw historical daily data set, we actually used a all function applied to this historical daily table before we allow the window function to process this historical daily table. The reason we use a all function on historical daily is because here we are constructing a measure. Okay, again, measure is gonna be used in a view, and in a view there's always a implicit future context. Okay, imagine a view where we have on the x-axis we have different dates, and on the y-axis we will have price at different dates and the moving average at different dates. Okay, so in this case the different points on the x-axis is going to work as a future context. So because you have different dates on the x-axis, so if you are focusing on a current point, say March 31st 2023 on the x-axis, then Power BI is only going to focus on data related to that particular date, because that date, that March 31st 2023, is going to work as a future and applied to historical daily data set. So we are only left with rows in that historical daily data sets that are related to March 31st 2023. Okay, because we basically apply this future of March 31st 2023 on that historical daily table before Power BI starts to processing that data. Okay, so that's useful sometimes, right? For example, if your measure is only going to show value related to that particular date, that's fine. Okay, you can just focus on data related to March 31st 2023. However, in our case, we're calculating a moving average. The moving average needs to utilize data not just related to March 31st 2023, but also the 12 days prior to the current date. So we need to basically utilize data related to other dates in that historical daily table, right? So we have to basically remove the future context the Vero will impose on historical daily table. So to do that, we use the all function. The all function basically takes all the rows from historical daily, ignoring any filter that might have been applied to this data set, okay, because of the Vero. All right. So that's the reason we use this all function. Next, notice that we have this match by clause, which basically confirms that this historical daily data set is identified by symbol and date. So each observation, each row in this historical daily table is a unique combination of stock symbol and date. Okay. Then the window function is going to use the partition by clause to partition this entire data set into different groups. Okay, each group is represented by a unique stock symbol. So, for example, we have Apple stock, and we have different trading days for this Apple stock. Then we have Tesla stock. Again, we have different trading days for Tesla. All right. So each of those blocks or each partition is going to be related to that stock, Apple. Okay, so that block is gonna consist of all the trading days related to Apple. Okay, moving to the next block or the next partition, we will have all the trading days associated with Tesla. Okay, so again, each block or each partition is all the rows related to one particular stock symbol. All right, that's how this partition by argument works. Then within each partition, this order by clause or order by argument is gonna to sort different trading days in ascending order. So if we are focusing on this partition of Apple, then all the trading days is gonna be resorted such that the first trading day is gonna appear as the first row, the second trading day being the second row, and so on and so forth, all the way to the last trading day for Apple. Okay, then move on to the next partition, say Tesla. Again, the first row is gonna be the first trading day for Tesla and all the way to the last trading day for Tesla within that partition. Okay, so basically these three clauses, order by, partition by, and match by, make sure this original data set of historical daily is going to be rearranged into a new format such that it's going to be kind of ordered block by block, and within each block we have, well, of course, each block represents a particular stock, okay? And within each block, we will have trading days sorted ascendingly, all right? So based on the rearranged data sets, the window function is going to retrieve a number of rows from that data set. So which rows are going to be retrieved is going to be determined by these four arguments at the beginning, all right? In our case, here we are basically trying to retrieve relative to the current row a range of rows. Okay, this REL argument stands for relative. So we're talking about relative positions. Okay, positions relative to the current row. Okay, in our case, this range of rows we're going to retrieve will start at 11 rows prior to the current row. Okay, this negative 11 means we're going to take a look at 11 rows prior to the current row. If it's a positive 11, it means 11 rows after the current row. Okay, so the sign, the negative, positive, tells Power BI, okay, whether we're talking about rows prior to the current row or rows after the current row. So this again, the first row we're going to retrieve is going to be the row located, the row located 11 rows prior to the current row. That's going to be the first row we're going to retrieve. The last row we're going to retrieve is going to be this one, okay? It's going to be 0 row prior to the current row. Well, sounds weird, but it actually just means the current row itself, okay? So 0 is the relative position of the last row we try to retrieve. and 0 basically stands for the current row itself. Okay, so put together, this 4 arguments basically says we're going to retrieve a range of rows starting from 11 rows above the current row all the way to the current row itself. So that's a total of 12 rows. All right, so that's how this 4 arguments works. So how does the window function determine what is the current row, what is the current partition? Okay, that depends on the filter context of the viewer. Okay, here we're working on a mirror. A mirror always appear in a viewer, and the viewer has implicit filter context, and usually that context is associated with the x-axis. Okay, for example, you may have different dates on the x-axis. Then if we are looking at a given point on the x-axis, we're basically focusing on a particular date, and that date is going to be the filter context for that point on the x-axis. All right, so the current row is basically determined by which point we're looking at on the x-axis. All right, if we're focusing on March 31st, 2023 on the x-axis, that's going to be the row we're going to look at. That's going to be our current row. All right, so the window function is going to retrieve 11 rows prior to March 31st, 2023. All right, which is, well, you can calculate 11 trading days prior to March 31st, 2023. Okay, and all the way down to March 31st, 2023 itself. Okay, so that's going to be the 12 rows the window function is going to retrieve. Regarding the current partition, okay, that's basically determined by which stock symbol we're focusing on in the bureau. Okay, in our case, we just have one stock, Apple. Okay, we don't have other stocks in the data set. Okay, assuming we have multiple stocks in the data set, then we usually use a slicer bureau. Again, you can construct a slicer bureau in which you can select which stock you're going to focus on in the bureau. Okay, so for example, you select a Tesla stock to focus on in your bureau reports, then you can just the selection of Tesla is going to determine what's the current partition, okay, for this window function to work on. All right, so that's how this window function works. After window function retrieve the 12 rows prior to the current row, including the current row as well, okay, then this next step is going to use the average x function to work on that 12 rows. Okay, those 12 rows are stored in this variable called w. Then the average x function is going to work on this w table, all right, row by row. On each row, the average x function is going to take the value of adjusted close on that row, all right. After taking all those 12 values on each row, the average x function is going to take the average of those 12 values and calculate and return that average value to this variable called MA. And this variable MA is going to be the eventual value returned to become the value of this mirror. All right. So basically what we're doing here, we are taking 12 rows prior to the current date, including the current date as well, okay? And calculate the average of the adjusted close price on those 12 rows, basically the 12 days before the current date, okay? We're taking the average price of the over the 12 days prior to the current day and use that as the value for this measure called moving average. So when we move on to the next day, which is going to be April 1st, 2023, okay? Then the future context becomes April 1st, 2023, means the current row is going to be the row related to April 1st, 2023. Then the window function is going to look 12 days prior to April 1st, 2023, and take those 12 rows and calculate the average closing price and assign that value to be the value of this moving average measure, okay? And then again, if you move one day ahead, April 2nd, 2023, then the future context becomes April 2nd, 2023, and that will determine the current row, Okay, and then window function is gonna look at 12 rows prior to the current row, which is April 2nd, 2023, and take the average of those 12 days and find the average closing price for those 12 days and assign to the value for this measure of moving average. So we define this measure moving average on a daily frequency. Now let's just put it in a visual. We go to this visualization pane, build visual. We click on this line chart. So there will be new line chart here, which is blank. Of course, you need to define the x-axis and y-axis. So I'll go with the date as the x-axis. Okay, the date under the historical daily. And I will have the adjusted close to the y-axis. And I will also have this moving average add to the y-axis. Alright, so now you can see we'll have both the daily price fluctuation and a kind of smoother change of those moving averages over time. So take a look at this visual. You will realize, well, although we just drag this adjusted close to be part of the y-axis, Power BI actually used the sum of this value. All right, but it doesn't really matter because here on the visual, each point on the x-axis is just one particular day. So there will be just one adjusted close on that day. So the sum of that single value is just itself. Doesn't really matter. You can use the drop-down list. The other ways you can kind of aggregate this value also will not change the value because we just have one single data point on each day of this x-axis. So for example, you can change to minimum. Still the graph looks exactly the same.